Hey guys, so we are back again now. We are going to be starting chapter 6 or module 6 that it says in your book. So we have 6.1, which deals with your algebraic expressions, and 6.2, which is going to start your one-step equations. So remember, the difference between expressions and equations is expressions don't have equal signs, where equations do. So we're going to take a couple examples of expressions about writing expressions. So if I have 4 more than the price P, so I gotta always look for my keywords, right? So I have 4, I know that that's an amount I'm gonna have to do something with, okay? And then it says more than. So what operation do you think we're gonna be using when I deal with more than? Yeah, I'm gonna be adding, okay? So I'm gonna go ahead and put that plus sign there. I know I'm gonna be adding a 4 to something, so I can put the 4 right after the plus sign. So if I read again, it says 4 more than the price P. So I know it's gonna be 4 more than the price, but they have it represented as P. So an equivalent expression to this word problem here, or this phrase, is gonna be P plus 4. That is 4 more than the price P. So let's take another example. So I have 5 less than 3 times the length L. So again, I'm gonna go ahead and figure out what my actual pieces are. So if you want, go ahead and pause, figure out what your key pieces are, and then come back. All right, so if I was looking at this, I know that 5 is gonna be a key piece for me, less than, and then I also have 3 times the length L, okay? So if I'm looking at it, I've now noticed 2 sets of words that deal with 2 different operations. So I have less than, which has subtraction, and then I have times, which deals with multiplication, okay? So let's go ahead and put our multiplication piece down first, okay? So that's gonna give me 3 times the length L. So I know it's gonna be 3 times whatever value it is for L. So I'm gonna put 3L. So it says 5 less than 3 times the length L, okay? So you have to be careful, especially when it deals with subtraction and when you deal with your less than signs. Or if it were to say subtracted from, okay? Typically, it's not gonna be in the order that it gave you. So this says 5 less than 3 times the length, which means that I'm dealing with 3L and then I'm subtracting 5, okay? So that is always gonna be the trickier one, just because the way it's worded is the way you kind of want to put it in order, but it's really not. You have to look at it. So it wouldn't be 5 minus 3L. It's gonna be 3L minus 5, okay? So that is pretty much just turning your phrases to expressions. So now we're gonna deal with simplifying expressions. So again, this is still 6.1. This is your algebraic expressions. This is gonna be what the HRW that's due for this week is on, okay? So let's say that I have the distributive property, or I want to use the distributive property to be able to simplify this. So I have 100 times 4, or 100 plus 4z times 20, okay? So this looks a little different just because when we have distributive property, we usually have a number that's on the left side of the parentheses, and then we can distribute. It still works the same way, you're just taking it from the right side. So I'm gonna take that 20 and I'm gonna distribute it, or I'm gonna multiply it by every term that's inside the parentheses. So I have 100 times 20, which is going to give me 2,000. And then I have 4z times 20, which is going to give me 80z. So now this was a positive 4z and a positive 20, which means that I still put a positive sign right in the middle. So let's think, can I combine these 2 items? If you said no, you're right. because this item here has a z, this one doesn't. That means that they are not like terms, so they cannot be combined. Now, if I had a value for z to plug in, I could definitely figure it out now, because I would multiply whatever z is by 80 and then add it to the 2000. Okay? So now another part of your algebraic expressions deals with factoring the expressions. So that means that you're trying to figure out what they have in common and removing it from both items. So if I look at 45C and 10D, I gotta think, what do they have in common? If you said the number 5, you're right. That is the greatest number that they have in common. Remember, we dealt with greatest common factor, where we had to kind of break down both terms and see what was the greatest amount that they had in common with each other. So if I look at it again, it's 5. So I would do 45C divided by 5. So I'm going to put the 5 on the outside. That's going to give me a 9C. 10 divided by 5 is going to give me a positive 2D. So notice they didn't have a variable in common, so those variables stayed inside the parentheses, okay? So let's say we also have one that maybe has 3 terms. So it has to be something in common with all 3 terms, not just 2 of them, not just 1, all 3. So if I were looking at these 3 terms, so I have 27, negative 9x, and a positive 15y, what do they have in common? Yep, 3. 3 is going to be the greatest value that each of them has in common with each other. So if I do 27 divided by 3, that gives me a 9. Negative 9x divided by 3 gives me a negative 3x. And then my positive 15y divided by 3 gives me a positive 5y. So you'll typically know that you're pretty much done when these terms that are still inside the parentheses no longer have anything in common. Now, if they still had something in common, that means that you originally didn't take out their greatest common factor. So you may want to go back and see what they have in common that's greater. Okay? So now we are going to jump into your one-step equations, okay? So we are dealing with rational coefficients, which again are our fractions and our decimals, okay? So remember that we're gonna go from here. If I have addition, my inverse operation is going to be subtraction and vice versa. If I have subtraction, my inverse is gonna be addition. And then if I have multiplication, my inverse is going to be division, and again, vice versa. If I have division, my inverse is going to be multiplication. So it always depends on what your original equation has for you to determine what inverse operation you're using. So let's take 1/3 n equals 4, okay? I need to solve for this n value that's here. I need to get it all alone. What's that word that I always used to use? Isolate. So we need to isolate this n value and get it all by itself so that we can solve for it. So if I'm looking at this part here, what are the 1/3 and the n doing? That's right, they're multiplying, which if we go back to what I just showed you, the inverse operation of multiplication is going to give you division. So that means that I'm going to need to divide both sides by a 1/3. Now, let's go back and think, okay, I'm dividing a fraction. That means I need to do what? Yep, I need to now multiply by the reciprocal or keep, change, flip. So I can put this over 1 just to make myself feel a little better. And then I can multiply across. So I get a 12 over 1, which again just equals 12. Okay? So that means that n equals 12. So I've now solved for the variable. I no longer need to do anything else. Let's take another example. So I have y plus 0.4 equals 2. So again, my whole point is to isolate this y value that's here. So my original equation has me adding 0.4. So that means that my inverse would be to subtract the 0.4. So I'm going to subtract it from here. Now remember that you need to line up your invisible decimal that's on this side, okay? So these get canceled out. I can bring down my y on this side, and then I can go ahead and subtract. So I'm going to do this. It gives me 0.61. So that tells me that y is equal to 1.6. So if I wanted to double check myself, I can go back and replace that 1.6 here. If I were to add 1.6 and 0.4, that would most definitely give me 2. Okay? So again, that's pretty much all that we're doing for these. So I'm going to go ahead and go over one word problem for you guys, and then that'll be it for today. So let's try one out here. Okay. So 15 tickets cost $193.75. So we have 15 tickets, and my total cost is $193.75. So what is the average cost of each ticket? Okay, so that means I first need to set up my equation. So I know that there were 15 tickets, but I don't know how much each ticket cost. So I know there were 15 total tickets times whatever value they cost, and that was going to give me a total, or was going to equal $193.75. So I've now set up equation just by looking at my word problem. So what are these two doing? Yep, they're multiplying, which means that I need to divide both sides. So I'm going to go ahead and use my calculator just for time's sake here. So I have my $193.75 divided by 15, and that's going to give me this weird number of 12.9166666666, so on, so on and so forth, okay? So that means that I'm going to go ahead and round it because it wants to know the average. So again, I'm dealing with money, which means it only is going to have 2 decimal places. So that means that each ticket is going to be about $12.92 or $12.92, okay? So remember that you can write an equation from any kind of word problem that you have, but you're always looking for those keywords that tells you what operation you're actually using, okay? So again, just a reminder, office hours 9 to 9:20. I look forward to seeing you guys and hearing from you. I love seeing you guys and hearing your questions. Just make sure that if you do have any questions, so please go ahead and write them down and ask, and either email me or send me a stream message in Google Classroom so that I can have those questions either prepared for you or already have that in front of me, okay? It kind of cuts down the time that it takes for me to find it, either on the HRW or on whatever I've assigned to you, okay? So again, look forward to hearing from you guys, and I will talk to you later. Bye.